This lesson deals with supplemental problem 4.6. You can find this problem in the ECE302 ebook in the Chapter 4 Supplemental Problems on page 12. Given this circuit here, which consists of two MOSFETs, resistor, a battery, and then some other part of a circuit such that the voltage here is 3 volts. Could you solve for the current ID1 and ID2, and then verify your assumed states if for transistor 1, K is 60 microamps per volt squared with a threshold of 0.8, and for M2, K is doubled with the same threshold voltage. Now note that there's a short circuit here between the gate and the drain of transistor 1, and that the gate source of transistor 1 is in parallel with the gate source of transistor 2. Now with the gate to drain being equal to 0, that's less than 0.8. So that means that M1 is either in saturation or in cutoff. If you apply 5 volts here and you have basically a resistor and then some silicon, you're going to get current to flow. So most likely the gate source is greater than threshold. Assume that we're in saturation. Go around this loop over here. The rise in voltage is 5. The drop is equal to 380K times ID1 plus the gate source of transistor 1. And that's this equation right here. Since we're assuming that we're in current saturation, let's put in the equation for that region, which is K times the quantity gate source minus threshold squared for transistor 1. K1 is 60 microamps per volt squared, and the threshold is 0.8. Multiply these two together, you get 22.8. If we square this, we get the gate source of transistor 1 squared minus the inner product times 2, and then minus 0.8 squared plus this term. Let's multiply this out. So 22.8 times the gate source of 1 squared, and 22.8 times minus 1.6 is a minus 36.48 times the gate source of 1, and then 22.8 times 0.64 is 14.592. Got this term, and let's bring the 5 on the other side of the equation. Let's combine terms. Got this first term, and I've got this multiplying the gate source of 1, but I've got another 1 plus 1 over here. Add that, so it's going to decrease the magnitude of this by 1. Minus 35.48, gate source of 1, and then this number minus 5 is 9.592. We have a squared equation. We could use the quadratic formula. Gate source of transistor 1 is going to be minus this term, 35.48, plus or minus the square root of this term squared, minus 4 times this term, divided by twice of this term. And you get two solutions, 1.208 and 0.348. And the threshold is 0.8 volts, so this is inconsistent with that. It becomes our contradiction. This can't be the answer, so this must be the solution. Drain current for transistor 1 is going to be K times the quantity gate source voltage minus the threshold squared, and that's about 10 microamps. Since the gate source is 1.208, which is greater than threshold, and the gate to drain is less than threshold, then our assumption checks. What about transistor 2? Well, the two gate sources are in parallel. The gate source of transistor 2 is the same as 1. It's 1.208. That's greater than threshold of 0.8. And the gate to drain we can solve for. Let's go up here in the picture. Here's the gate, and here's the drain. We know the drain is 3, and we just solve for the gate voltage. Let's take that difference. 1.208 minus 3 is a minus 1.792. That's less than 0.8. Therefore, M2 is in saturation also. We can use our saturation equation for transistor 2, which has a K of 120 microamps per volt squared, a gate source voltage of 1.208, and a threshold of 0.8. Quantity squared gives me about 20 microamps. That's roughly double the value that was here. That's because this was doubled. We'll learn later in IC design courses that you can change the effective value of K by playing with the width and length of the gate of the transistor. In this particular case, the width of transistor 2 is double that of transistor 1 for the same length. And this is supplemental problem 4.6.